So I'm a little bit nervous. So let's begin. So I'm gonna start with the basic, which is what is a lubricant. Lubricant is
press please F5.
F5.
Yes. Okay, thank you.
There you go. So as I say, I'm gonna start with the basic. What is a lubricant? Lubricant is a substance introduced to reduce friction between surfaces in mutual contact, and which is ultimately reduce the heat generated when the surfaces move between them. And it might also have the function of the transmitting forces, transporting foreign practices, or heating or cooling the surfaces. And the property of the reducing friction is known as a lubricity.
Okay, questions? Ask questions. What generates heat? You said that the idea is to reduce heat.
Generate the heat is when the surfaces move between them.
Mm-hmm.
So, and the other.
We have some kind of friction.
Yes, the friction.
Okay. And how they can reduce the generation of heat? How?
It's
because it's mentioned to reduce. How?
It's like how can I say? Like lubricants between the surfaces can reduce the heat and reduce the friction, which is
yes. Okay, so they can reduce the friction by interposing somehow. The engineers can do this to interpose the lubricant between two surfaces, and secondly, by removing the heat. Usually, the lubricant oils usually they take the heat away, and there's some cooling devices that cool they cool it down. So we have two ways of reduction of the heat. Okay. Okay. Now's the piton. And you gave them points if they ask.
Oh, okay, there you go. So, and I wanna talk about a little bit about viscosity, and I wanna ask anybody if anybody knows what is viscosity.
Measure of the internal friction. Measure of the internal friction.
So
Don't look at me, just.
I cannot give a point. So.
Why not?
Point.
Okay, so
How many?
Two.
How many points?
3, 4.
She's
So let me explain what is viscosity. Viscosity is the fluid resistance to flow at given temperature, which is important. This part is the greater the resistance to flow, is the higher the fluid's viscosity. So, any question? Okay. No? Okay, we can say for other thing for viscosity is lubricant's most important characteristic. So if we explain that for any oil lubricant system, oil viscosity is considered as the most important parameter, and the main function of the lubricant oil is the create and maintain a lubricant film between two moving steel surfaces, and this function is very much depend on the viscosity of oil itself. So, any question? And I want to ask.
It's not very correct because the viscosity is a property of the lubricant.
Okay.
It's not affected by the moving surfaces. They could be metal, could be wooden, could be. But it's not.
This is a viscosity about for oil.
Yes, for oil and for other lubricants, but this is a property of the lubricant.
Yes.
Okay, is that right?
Yeah.
Okay. So let's.
He mentioned that it depends on the metals. Okay.
Okay. Let's begin with the type of the lubricants. Anybody knows how many type of lubricants we have?
Let's go back to the
3.
viscosity. Sorry.
3 types.
1 point for you.
can we measure viscosity? And what is the dimension of the viscosity? 3 points. What is the measure of viscosity? What units? I took the question to you. Because you introduce the term viscosity, and we have to measure it somehow to evaluate it.
I mean,
The units.
I just explained a little bit viscosity because my topic was lubricants. So
Yes, but this is the proper measure. Measure. How can we measure it? What is the units that we use for measurement of viscosity? Kilograms? Sorry? Definitely not. Sorry? Somebody said. Това не е в C. Okay, 1 point. It's not in C. And in C. Намерихте ли? Бързо работите с интернета.
okay, so let's begin.
Go.
Let's
Ама, чакай да
continue.
му усложим нещата. За коя вискозити? Колко вида вискозити? How many types of viscosity you know?
It's a question for me.
Yes.
There were 2 types.
And they are dynamic and kinematic viscosity. За следващия път вие ще повторите. Значи, поне ще правите голяма презентация viscosity. Ще включите във вашето, давам ви още viscosity. Какво е viscosity? Dynamic, kinematic. We measure in. Okay? 5 minutes. Okay.
Okay, so let's continue with the bearing lubricants. There are 3 types of bearing lubricants, which is oil, grease, and soil film. So let's.
Question. Let me ask questions. Ask. Is there any other type? We mentioned it last time.
Air.
Air. On point. So, are you going?
One point.
2.
1 point. So we have solid, liquid, and gas. 3 types of lubricants.
Okay, let's continue with the oil. There are 2 types of oils, which is one is petroleum based, and another one is synthetic oils. If we give an example of synthetic oils, there are silicone, diester, PAOs, and fluorine compounds. And another important thing is about oil lubricant is temperature range, viscosity. Evaporative rates are key characteristic to consider when the selection an oil. So another lubricant.
Oh, wait. So you said that oils we subdivide in 2 big groups. Let's say petroleum or natural, I would say, and synthetic. What is the difference? First question to you, after that to the audience. What is the difference? Why we have 2 types? Petroleum, or let's say natural, and synthetic. What is synthetic?
Synthetic is chemical, kind of.
Why do they design those? Because these are designed.
Yes.
They are designed. Those are natural, those are designed. Or we create them somehow for a certain reason. Why?
For different machines, probably.
With certain parameters which natural cannot.
Absolutely, yes. We need some kind of extra, let's say, characteristics.
Oh yeah.
Extra parameters. And okay, this is for the purpose. Should we done? Can
I don't know.
I? It's up to you.
2 points as usual.
I'm used to as usual. What does it mean? As usual. 10 points.
Always. No, I mean,
1 point.
you mostly give 2 points, right?
Okay, 2-2. I forgot my question. What could be that desired, let's say, characteristics or desired parameters?
Viscosity.
Could be, why not? Could be different viscosity.
Yeah.
And how? Okay, guess. how do they produce the synthetic oils? What is the difference between synthetics and petroleum-based oils?
Petroleums are more like natural oils,
Yes.
and as I said, the synthetics are more like chemicals.
So they put their
They
some
mix some chemicals.
additives.
Mm.
Yes, they put some additives in order to, let's say, improve. Usually they improve.
Mm.
They improve the parameters. Could you give us some kind of example of this? Synthetic oils and some kind of example of the differences between the two oils.
I give example, which is like synthetic oils are like silicones, for example. Difference are
Usually, what could be the difference? What could be the improvement? Aš ви дам това изпит. What could be the improvement? Две точки. Защо ги правим? Какво мога да подобря? Какво значи качество? Какво значи качество?
Which they evaporate.
They do not burn. They never evaporate. First, хайде да е, инженеринг. Мислете. Имате вода, да кажем, и имате масло. Това е разлика.
maybe cooling.
Could be. But somewhere at the very end.
Temperature. Maybe
Total.
different temperature.
What does it mean, different temperature?
I mean usage as a different machine.
Okay,
which is
they
getting
can
more
withstand, yes, synthetic oils can withstand high temperature.
high
First.
temperature. Yes.
First. Secondly, they could have constant viscosity, because if you remember, I showed last time the diagram with viscosities. They drop with the temperature. They could have better, let's say, better characteristics in different temperatures. They could have more or less, more slightly going down viscosity with the temperature. What else?
Maybe for different
This is
frictions.
спалёщо на Великден. What else?
Maybe for different frictions.
What does it mean, different frictions?
I mean, all the materials, all the machines have different frictions.
Първо прочетем какво пише.
You want to write?
Temperature range, viscosity. They can, for example, they can withstand heavier loads. This is next one, heavier loads. And the first one, we are still going to the first one. Durability. If you change, I remember, I'm much older than you, but in my first car, I changed oil in every 5,000 kilometers. Now I change it with synthetic oils, 25,000-30,000 kilometers. 5 times they improve the durability.
Yeah, it's changed maintenance cycle.
Absolutely, it's over there.
Oh, yeah.
Finally, we come up to it. Okay, go.
The next lubricant is grease lubricant, which is a little bit thicker than oil. And this thickness consists primarily of metal salts, which is lithium, sodium, aluminium, and calcium, organic or inorganic compounds. Any questions? And
Okay, these are solid, let's say, these are solid lubricants. Grease is the most popular one, but nevertheless, there are some others. Please name. Even in Bulgarian or in English. твърди смазки.
Fillers.
No. Just name it. What else? Of course, grease is produced on the base of on oil, natural oil, but there are some others. The first one, let's say on the top is sludder. Явно намерите забравих името. Sludder. Пречникът. Слюда, виждали ли сте?
Да.
Така, това е най-твърдият лубрикант.
They have different grades of grease.
Yes, they have, but that one is natural. Как се казваше слюда, бе? Аз го имам в моята презентация. Мик, да. Една точка. Нещо е. Natural. Before greases, what did they use in ancient time? Различни видове парафини. Парафин, айде го намерете. Пак следваше.
Wax.
Кой каза wax? Една точка. Wax. Това са, значи правим слюда, парафин и после идва грес.
Yes.
This is the range. Okay.
And
What do we use? Okay, go.
And most greases used in rolling element bearing are NLGI, which is grade 2. As I say, there is different grades of more thicker or less
No, what is the difference in grades? Why do we have grade 1, grade 2, grade 3, grade 4? What is the difference?
As I know, it's for different temperatures, different viscosity.
Different viscosity. Yes. So, по-плътни са.
Mm.
Different viscosity. Okay, next.
Okay, next one is solid films lubricants, known as modi-dry film lubricants. This is a little bit different than oil lubricants and grease lubricants because they are used in extreme situation, which is oil and grease cannot survive. We can give example of like high temperatures, vacuum, like dusty area, which is too many dust, which is grease and oil cannot survive. We use those kind of lubricants in these machines, and it's like how can I explain? It's like coating the surfaces with this element. It's like a painting kind of coating, and what can I say? Solid films are engineered on specific application by application basis. So those are solid films lubricants.
Name some of them.
Mm,
The same, or
silver, gold.
graphite is over there. Yes, silver, gold,
Yeah.
gold, of course, but they're very expensive. Graphite.
Yeah.
Graphite is the most
Yeah,
let's say,
graphite.
frequently used one.
And
Okay.
there is a MOS2, which is a low friction coating. So the other subject is
Selection.
of the lubricants. So this is critically important for performance of ball bearings and affects life, torque, speed, noise, grease migration, outgassing, temperature effects, and rust prevention. So also they have some advantages and disadvantages. If we can say for advantages of grease, they are a dependable system, adhere to bearing, wouldn't leak out of hull because they are a little bit thicker, and work in pressurized systems, which is a little bit more heavy duty. And if you talk about for oil lubricant advantages, they are bearing run cooler, reduce friction, prolonged bearing life, and constantly replenish lubricant to the bearings. And also, if we talk about disadvantages of these lubricants, for example, for grease, bearing run hotter, increased friction, increased bearing wear, which is opposite than oil bearings, those three, and doesn't replenish to lubricant to the bearings, and also required regular services. And also disadvantages of the oil, they are hard to leak hard to control because they're not like thicker like grease, and can't use in pressurized systems. And complete loss of oil can lead catastrophic failure. Like, for example, if you leave your car engine without oil, you're gonna have a little bit trouble. And also, like grease, there are also regular service required.
Questions? Ask questions. No questions at all.
Nobody wants points. Okay, in this figure, I want to show a little bit how the surfaces work lubricated and non-lubricated. In this figure, we can see, which is non-lubricated surfaces, when the speed increase and the friction is increased also. And the other case, lubricated with oil, here we can see, when the speed increase and the friction is going lower. So that's why we use lubricants.
This is part of famous Strybeck diagram that I presented last time. With increasing of the speed, the coefficient of friction or friction as a whole decreases.
Yes. And here I want to show you guys some pictures, which is some deformations of bearings, which is known or low lubricants usage. And in this picture we can see this is kind of not deformation, it's definitely damaged very badly, this bearing. And in this picture we can see there is some rust going on the sides, and there is some little deformation, little like chopping, like little holes going on. And this last picture, we can see some dryness, we can see some cracks going on here, and some deformation also, some damages. This is what's going on without lubricants on the surface.
No, I'm doubt. Let's go to the first one.
First.
And this one, I'm doubt that this is the result of lack of lubrication. So heavy deformation. This is another reason for this. I cannot.
Maybe.
Sorry.
Maybe I just.
No, it's not because of lack of lubrication. This one, something else happened there, but not lubrication. Second one.
Because I check it, looks like no lubrication.
Yeah, I can read it, but I doubt that it's happened because of this. Next picture.
Next picture is here.
This we call this failure. I'll explain next time about this failure. We call this failure pitting, and it's a result of surface fatigue, but it's not because of the lubricant, not because of lack of lubrication. This failure usually happens when the lubricant is available between the contacting surfaces. If the lubricant, okay, we have two types, there are many types of failure, but usually we have two very specific types of failure, when we have lubricant and without lubrication. With lubricant is this one, and the next one, the next picture as well, we call this pitting or surface fatigue. I'll explain next time about
This one or this one?
Please, for two questions, what happens when the lubricant is not presented, not available between contacting surfaces? Sorry? Could happen задиране. Как е задиране? Sorry? Scoring. 1 point. Scoring. Scoring. А какво е задиране? Scoring. Yes, it's when lubricant is not presented, we call it. Sorry? А как ще го познаем? Това е неизносване. Значи, so the first failure is Износване как е на български?
Wearing.
Not точка. Wearing. So with lubricant we have pitting. Without lubricant we have износване or wearing. А износването, what is износване? Removing of particles. So when they contact, particles remove. Задирането or scoring е micro-welding. Значи това е микрозаварка. Когато стават повърхните, when the contacting surface is under very high pressure, we have some kind of micro-welding and particles of one surface glued or stick to another surface. While wearing means that we remove just particles. Scoring, from this surface they go to that surface, and even after that they produce scratching on the other surface. This is the difference. I'll explain about the failures probably next time, because as industrial engineers you'll be asked in the future to, let's say, to recognize, to fix, to select what is the failure and what is the resulting, let's say, what causes that failure. Разбрахте ли? Като индустриални инженери ще ви питат защо. Вие много рядко ще правите някакви големи неща. Обаче като стане нещо, ще ви вика, че ти умните да те завърши английския факултет. Трябва да видят сега. Ама така ще е. И ще ви, що се щупи това бе, шефе? И трябва да кажете защо се е щупило и какво е станало. И защо е станало. И трябва да кажете как да го поправите. И като видите повредата, трябва да кажете, това беше износване, това е задиране, а това е питинг. Като е питинг, значи там има много масло. Ама защо е питинг? Аз ще ви обясня следващия път. А ако е износване, там няма масло. Ако е задиране, има масло, но натоварването е много голямо. И за да няма задиране, не трябва да имате еднакви метали. Трябва да са различни повърхните. Това особено при зъбни колела, при лагери. Не може да имате задиране, ако са различни металите. Обаче, ако ви направите от един метал, задирането ви е гарантирано. Или трябва да направите повърхните, да ги направите с различна твърдост и различни качества. Ама трябва да го знаете. Добре, next.
So I'm gonna tell my references, which is Wikipedia, YouTube, and www.iseric.com and www.kitywake.com. It's a website about lubricants and bearings. So that will be all. I have also some quick video, but I don't know if it's ready.
Чакайте малко, ще караме да взето, защото аз им пусна много тежък съвет и ще свършим малко по-рано. Трябваше да ми изчакам.
Очень.
Open with.
Образуйте се малко.
Какво? Що?
Крайчук изкъпя.
Не, той го каза, аз предам.
Образуйте се.
Що?
Имате нужда.
Ти като си измукаш, толкова иска той, че това не е да
За мен това решението на всички бъде.
Какво бе?
Не
Сигурно. Vale.
So there is a little video, maybe you can see it.
Интересно. You can find really nice movies in YouTube about everything.
Mm.
And that's actually explaining that.
Go very slowly from the memory stick.
About 10 minutes. And 5 minutes. It shows
Много хубав питинг, класически много хубав. Това е. What is this? Една точка. Кой е това?
Питинг.
Не, като машинен елемент. Кой е това? Кой е това? Две точки, бързо. Не. На български?
Амортисьор не е.
Не. Тук имаме триене, много интензивно триене, специален машинен елемент.
Аз не знам.
Червяк. Worm. Не така беше червяк?
Да.
Worm.
special kind of mixed film lubrication, elasto-hydrodynamic lubrication, or EHD, applies to conditions of extreme high contact pressures. Two things happen in EHD lubrication. First, the surfaces of the contacting parts deform elastically, spreading the load over a wider area. Second, the viscosity of the lubricant momentarily increases dramatically, increasing its load carrying ability in the contact zone. The combined effect is to trap a thin but very dense oil film between the surfaces. As viscosity increases, sufficient hydrodynamic force is generated to form a full fluid film and separate the surfaces. Lubricants must do their job under extreme operating conditions, conditions which break down the lubricant and reduce its effectiveness. Lubricant breakdown can be caused by many types of extreme conditions. Premature wear and component failure can be the result of lubricant contamination, reduced or interrupted oil film, and inadequate levels or incorrect types of lubricant additives. Lubricant contamination by foreign matter, such as dust, water, or combustion byproduct, is one important cause of component wear or failure. Dust particles are highly abrasive and can plow or ridge metal surfaces. Water can be a contaminant in crankcase lubricants since it's a byproduct of the combustion process. It may also enter lubrication systems by condensation, promoted by heating and cooling during operation and storage. In the presence of air, water can promote rust, oxidation, and corrosion of unprotected metal surfaces. Other byproducts of combustion, such as soot and other particulates, can also contaminate the lubricant, causing abrasive wear, lubricant thickening, and clogging of oil passageways. In addition, unburned fuel causes lubricant contamination that lowers its viscosity, reducing the thickness of the protective lubricant film. When these contaminants reach the lubricant, they can reduce its performance over time by changing lubricant viscosity, altering lubricant chemistry, or adsorbing certain anti-wear additives out of the lubricant. This shortens the effective life of the lubricant and reduces its capacity for protecting the equipment. Fuel, oil, and air filters help to minimize lubricant contamination, but failure to change filters or fluids regularly, especially in extreme operating environments, can result in lubricant failure and equipment damage. But fluid and filter changes take equipment out of service, reducing its efficiency. That's why the lubricant itself must be formulated with special additive packages to counteract the adverse effects of contamination. Another cause of component wear or failure is a reduced or interrupted oil film, the result of using the wrong lubricant viscosity grade, or of not changing the lubricant on schedule. Lubricant with too low or too high viscosity for the application, or with a viscosity which has been altered by contaminants, will not provide adequate protection. Using lubricants in applications for which they were not formulated, gear oil in an engine, for example, is yet another cause of premature component wear or failure. That's because misapplied lubricants may not have the correct viscosity or may not contain adequate additive levels or types. So, selecting the right lubricant with the correct viscosity grade and performance level for the application is the best way to avoid excessive wear and to increase the equipment's life expectancy. In choosing lubricants, always follow the original equipment manufacturer's recommendations for type and fill intervals. Clearly, there's much more to lubrication than simply applying a bit of oil to moving parts. In this chapter, you discovered that there are complex physical processes at work. You saw some of the causes and effects of friction, of different lubrication regimes, and how the lubricant's job is made more difficult by the various contaminants that may be present. Understanding the different lubrication regimes and the effects of contaminants provides a good basis for exploring the role of lubricant additives.
That's all.
That will go.
Hmm?
That will go with the video. And gonna be finishing any questions then?
No question?
No.
Okay.
Everything?
Question? No?
So then, thank you very much.
Okay. How many points?
20.
20?
25.
Okay, 17.
70.
17. Okay, good.
you very much.